Okay, let's finish off this binomial probabilities categories here. We've got 5 or 6 problems. Problem 3 is a manufacturing scenario where you've got a lot of 50 products. The defect-free probability of success, if you want to call it that, is 0.99. And you're asked, what's the probability that you have no defects in that lot of 50? At least one and at least two. Okay, so you're going to find, I mean, this is true of probability. Probability often turns into kind of a brain teaser, brain twister exercise. That seems, for whatever reason, to be particularly true of binomial type problems. And you're going to see that here, and you're going to certainly see it in the next couple of problems that come up. So again, this first question is, what is the probability of no defects in 50? Well, I'm dealing right now with the probability of being defect-free. So that means that Q is the probability of failure, and that's 0.1. So, gosh, I wish I had my calculator. I do. So all I'm being asked to calculate here is the probability of exactly 0 defects, okay? So since I'm looking for exactly some number, I'm going to be dealing with the PDF. It's always in PX, in PX 50, but the probability in this case that I'm interested in is the defect probability, 0.01. And I'm interested in a lot of 50 with this defect probability. What's the probability that I see 0? So, I always like to do these in real time, just so that you can see that there's really nothing to it. I just found binomial PDF. I'm entering 50 as in. I'm entering 0.01 as P and then 0. And I come up with 0.605. Okay? That's the first answer. Second question is, what's the probability, I check 50 of these, what's the probability that I get at least one defect? So let's think about that. What's at least one mean? Well, if I check 50 and I find one, that's at least one. If I check 50 and I find two, that's at least one. Check 50, find three, that's at least one. So P of at least one is P1 plus ... plus P50, okay? So I don't want to calculate all of those using binomial PDF. Instead, I would use binomial CDF. But hold on a minute. Every time we see at least one in a probability problem, we're trying to go think about what the heck is the complement. Because if I can find the complement easier than I can find at least one defect, then I'm just going to subtract the probability of the complement from 1 and have at it. So what is the complement to at least 1? It's none. All right. So this probability is 1 minus P0. There's P0, so this is 0.395. Tried to screw that up. So on to problem C, part C. Part C says find the probability of at least 2. Well, the probability of at least 2 is P2 plus ... P50 again. So let's always think in terms of complements. In this case, the complement of at least 2 is 0 or 1. P of 0 plus P of 1. Now let's use the binomial PDF or CDF. And let's calculate binomial CDF out of a lot of 50 with a defect probability of 0.01. What's the cumulative probability up to 1? That is, what's P0? This is P0 defects plus P1 defect. If I subtract that total sum probability from 1, that's at least 2. So off we go to distribution, go find binomial CDF. I've got 50 trials, I've got 0.01, I've got an x value of 1. Okay, and I'm pasting all of that in. I get the answer 0.91. I subtract that from 1, and I get, did that wrong. I think I get 0.089 if I'm not mistaken. 0.91, yeah, I think that's right. Okay, that's problem 3 of the brain twister group from 3 to 6. So let's go on to 4. All right, on to problem 4 in this binomial probabilities section. Problem 4 is about eggs in the grocery store. There is a 3% defect probability that you've got a cracked egg. And N is 24, is 2 dozen. P, again, P in this case, success means a cracked egg, and it is 0.033%. First question is, find the probability that in these 2 dozen eggs, nobody's cracked. So P none is the same thing as P zero, is in this case binomial, since I'm looking for an exact value, binom PDF, and it is 24.030. Okay, and if you were to work that out, you would find 0.481. That solution's given to you in the back of the workbook. At least one, we've done this a couple of times now, at least one is the complement of none. And so we're going to say that this is equal to 1 minus P0. And P0 is 0.48. That makes 0.481. That makes this probability 0.59. And exactly 2, this is different than the preceding problem, which asked for at least 2. Exactly 2 is P2, and that is binom PDF 24.232, and that number I believe is 0.127, and it's just like that. We're done with problem 4. All right. Okay, I'm trying to hustle along and finish up these 6 problems and get them on to part 3. So we need to hurry a little bit. This problem, it says we're going to roll 2 die 20 times. So the number of trials is going to be 20. And it's interested in the probability of rolling a sum of 5. So let's think about what that could be. All right, I think you probably remember by now throwing 2 dice, the sample space is 36, right? The ways that you make 5 are 2, 3, or 3, 2, 1, 4, 4, 1. So there's 4 ways out of 36. Let's just leave it like that, 4 ways out of 36. And that's the, I guess I can call that 1/9. And that's the probability of success. Then the problem say, find me the probability of successfully rolling 5s exactly 6 times out of 20. That's what that means. Exactly 6 means we're going to go to binomial, PDF, we're going to load NPX. We always load NPX in that order. 20, 1/9. Remember, you can put 1 divide 9, and the calculator will take care of it. And exactly 6, and that is 0.014, I hope. Is. At least 4. This is part B. How do we do at least 4? What is the opposite of the complement of at least 4? It's 0, 1, 2, or 3. All right, so in this case, what we're going to do is subtract from 1 binomial CDF 20, 1/9. And now at least 4 means I have to go up to 3. I have to have P0 plus P1 plus P2 plus P3, and that's what I get when I put in binomial CDF, and that number is 0.175. At most 5, problem C, is 0, 1, 2, 3, 4, 5. Right? Not 6. 6 is not at most 5. 5 is. This is straight on binomial CDF 20, 1.19, and, I'm sorry, what did I say, 5. Okay, and that answer is 0.987. And then finally down here, I wanted to make sure you remember that the binomial, all these special distributions have special formulas for their mean and standard deviation. The mean for a binomial, in fact, let's write binomial, binom, the mean is equal to n times p. 20 times that 29ths, that number is 2.222. And the standard deviation is the square root of npq. Q is 1 minus p, so it's this number times 8/9, take the square root. Trust me, that number is 1.405. And there you have it, there's problem 5. Okay, problem 6, let's do this in 2 minutes, all right? Problem 6, Tim's shooting foul shots. He tries 30 foul shots. He's got a probability of success of 70%, 30 and 70. Your first ask for what is the probability that he makes exactly 21. Exactly 21 means binomial PDF NPX 30.721, 0.157. At least 21, remember, let your mind switch over to complements. The complement of at least 21 is 0, 1, 2, 3, up to 20. So we'll go 1 minus binomial now CDF, 30.7 up to 20. Subtract that from 1, you get 0.589. At most 21, that is exactly what binomial CDF is all about. That returns for 30 trials, 0.7, the probability of getting 0, 1, 2, ... or 21 shots, meaning at 21 successes, meaning at most 21, that's 0.568. This is the only tricky one on the page. If you want the probability of 18 to 20, hey, just go calculate them individually with binomial PDF, or get clever. Write down binomial CDF up to 20, okay, that'd be 0 to 20. Subtract off binomial CDF 0 up to 17. You're left with 18, 19, and 20.357. See you soon.